Okay, so well, thank you. I find it rather difficult to follow on such an excellent talk that we just saw. However, luckily we do change tack a little bit, and we transition from volume EM more to the instrumentation side, and specifically on the TEM side. But in any case, to my previous speaker, that was excellent. Thank you very much. That was a very informative talk. So to get going, just to start off, thank you for the opportunity to talk to you about our newly released JEOL TM. The purpose for this talk is to also give a little bit of a little peek behind the curtain about the design philosophy and the thought process that went into designing this new general purpose transition electron microscope, specifically because it veers off of the standard formula that has been used by JEOL TMs of this range before. So hopefully it would everything that I say would make sense as we go along. Now, considering that the audience for today's talk is largely life scientists, I just want to give a brief overview of the JEOL TM range, specifically for the life sciences side of our portfolio. So on the left-hand side, we have the newly released GEM 120i, which is going to be discussed in more detail in this talk. And then the next one in the range would be the 200 kV Lab 6 instrument. So that's our GEM 2100 Plus. Then we have the 200 kV field emission system, the GEM F200, which comes in two forms of field emission guns, either a Schottky or a cold fig system. And then on the right-hand side, we have the high-end cryo systems, the 200 kV and the 300 kV cryo arms. Now, specifically, we want to focus on the 120i. Now, the design philosophy of this new general purpose tungsten TM was to create a system that takes into account all of the requirements of the modern microscopist. Now, within the modern microscopist is a duality of needs. Now, on the one hand, some microscopists prefer systems that has a wide range of automatic functions, a TM that is above all easy to use, which largely functions as a black box. Your sample goes in, data comes out. But on the other hand, you have microscopists that require a system that can be customized and configured to allow many different kinds of experiments to be accommodated within a single experiment. So I believe that the new 120i successfully caters for both kinds of modern microscopists. And I'd like to use this talk to convey these points. So the 120i is a transmission electron microscope with a maximum accelerating voltage of 120 kV, and it can take both tungsten or a Lab 6 filament. And it features an objective lens that captures high contrast images from low to high magnification. There's 4 key features to the new GEM 120i, which I'd like to be discussed in more detail. The new improved compact design basically realizes a 50% reduction in a physical footprint. There is a LED or visual indicator which allows users to easily observe the microscope status. There's numerous software and hardware improvements that have been made for simplified operation. And there's improved flexibility in customizability, which is realized with the extensive software and hardware additions that can be made either during or after purchase. So with the GEM 120i's compact size and simple operation, it is a useful tool for every user, and I'd like to expand on these 4 features to highlight this point specifically. A significant redesign was made of the TM external appearance, and the resultant compact size allows it to fit into almost any installation location, which supports users from normal use, but also to maintenance side of things. Now, how was this done? Historically, a TM of its class required about 4 to 6 separate units, which in the end took up quite a lot of physical footprint. Whereas the GEM 120i has a 50% reduced footprint by combining these units into a single unit. So basically, what you see in that box is what you get. There's no additional components that needs to be found a place to live. The result is an instrument that is shorter than 180 centimeters in height, which allows much easier planning for the installations to be done. The smaller footprint has many quality of life advantages. The filament replacement mechanism has been completely changed. The instrument can be operated without the need for any physical control panels. and the sample exchange can be done from a sitting position. Now, we also improved the vacuum system by offering a oil-free pumping system. Upon discussing with customers the previous model TM, we learned that even though the standard filament replacement method was easy enough, many customers still don't feel comfortable doing the filament exchange themselves. So to address this, the filament exchange system was completely redesigned by making use of a cartridge type filament, which helps make filament replacement easy and safe. So here's the individual steps of how the filament exchange process works. On the side of the microscope, you've got a panel that you lift off. First off, you'll vent the microscope. You'll open this little panel that I just alluded to now. You'll open the little port to expose how the filament cartridge looks. Then you've got a nice little jig, which you'll use to grab hold of that filament, lock it in place, remove the jig, and there's your filament for you. You can replace the cartridge, or you can take out the filament from the Veinelt, clean that, and then replace the cartridge back. There's no need for height adjustments anymore. You then take the same jig, put it back into the microscope, go from the unlock to the lock position, remove the jig, and close the door again. And basically that's all that's required in order to do a filament exchange. So it's a significantly easier process for the general user. Also, to create a system that's easy to monitor its operating state at a distance, the instrument has an LED light at its front, which the color changes depending on the state of the TM. So at a single glance, you can see what the system is doing. And this also helps you to guide you during the whole sample loading process. But the specimen exchange process itself has been sped up significantly, because now the emission stays on during sample exchange. So it just gets so much quicker to go from one sample to the next. Now, in order for users to focus only on data collection, a whole series of auto startup, auto configuration, and auto alignment procedures have been created and integrated into the normal operation of the microscope. Basically, it only takes 4 steps from loading a specimen to completing your observation. First step, after you insert your sample, the user only needs to initiate the startup process by selecting the Start button. If this is the first sample loaded, then the voltage increases, the emission starts automatically. If not, well, we just open a beam valve. But following this, a low magnification image will be acquired of the TM grid. And this low magnification image then allows you to use that for navigation purposes. You can just click and the stage moves to wherever the position is of that navigation image. So there's no more time wasted scanning over your TM grid blindly in order to find your resin sections. You can just see what you have at a easy glance. Then during operation, you can rely on the auto functions. So you've got autofocus, auto Z height adjustment, auto beam centering, and many others to automate the optical adjustment of the instrument for you. These automatic functions are available regardless of the type of bottom mount camera that you use, and any user will always be able to rely on these automatic features. When you're done with your data collection, you just initiate the sample exchange system. And again, since we're keeping the emission on, it's really fast transition on to the next sample. This is a quick overview of how the graphical user interface looks. And it shows us where the 4 little steps are indicated. But to accommodate the need for institutions to keep their energy consumption to a minimum, an eco mode that cuts power consumption by up to 80% is available on this TM. And then finally, the increased level of automation provides an operation environment that does not require an operation panel. And all the microscope operation, for example, changing the magnification, the brightness, the focus adjustment, stage or beam shift control, and many more, all of this can be fully controlled remotely by the computer mouse with this JEOL Aero tool. So this enhanced TM control system, together with fully automated apertures, eliminates the needs for switching magnification modes and manually controlling the aperture insertion or retraction when going from low magnification to high magnification. So basically, all you need to do is use the mouse wheel, zoom in on the screen, and you'll transition from the lowest up to the highest magnification, and all your aperture controls would be controlled automatically for you. Also, the instrument has a function to retain the brightness of the electron beam setting to a specific value and keeping that constant across the magnification range that you use. So basically, all that you need to do is use your mouse wheel, zoom in, click the image, and that's it. With all the quality of life improvements that I've highlighted in the previous slides, I've hopefully made it clear that the TM design has been changed to accommodate, well, the new style of modern microscopist that prefers to spend the majority of instrument time acquiring the data. But what about the other kind of modern microscopist, the kind that would like to configure the TM to accomplish many different kinds of experiments or techniques? To allow this to happen, GEM 120i supports a wide range of configurations and retrofits to meet the imaging needs by adding new functions during or after the purchase. And I'd like to highlight a few of these customization or retrofits that can be done in order to bring out new capability to a specific or single kind of instrument. The normal JEOL quick change holder has been redesigned for improved strength and easier grid loading, but there's also multiple other specimen holders which will make any form of specialized data collection routine. One of these is a specialized silicon nitride window chip, which are JEOL-made high-strength silicon nitride films, which allows large field of view areas to be captured without having those pesky grid bars in the way. Another configuration is you can configure any number of bottom-mounted cameras to this system, including the JEOL-made high-resolution 19-megapixel CMOS camera, which is called the Sight Sky. And there's also a host of both JEOL and third-party software packages that are compatible with GEM 120i, which I will be discussing in much more detail later on. So again, take into consideration demands of the demands for flexibility and customizable instruments. You can also mount attachments that are compatible with allowing the system to do scanning, elemental analysis, or cryo-imaging after delivery of the system, regardless of the configuration at the time of initial purchasing. So it just allows you to do so much more future-proofing later on without being held back based on what it is that was actually bought in the first instance. So I'd like to expand a little bit on the advanced imaging software options. So showcased here is the Shotmeister and STEMmeister software designed by JEOL's specialist software development team, which allows automated data collection to be done easily. Dual control of the stage and the deflector coils enables polygon-selected panoramic imaging at an unlimited size ranges with the limitless panorama software. And these panoramic images are acquired in a guided stepwise manner, and multiple areas can be acquired consecutively using the macros function. So the software easily deals with automated image stitching to create montages without any seams or misalignments, and the brightness correction feature blends and smooths out any brightness irregularities that might arise during the acquisition. With the inclusion of JEOL EDS, elemental mapping montages can be easily accomplished. And also correlative light and electron microscopy, or CLEM, is also available. You can perform positional alignment by selecting the same 3 or 5 points, allowing you to use an optical image for navigation purposes instead of a low magnification EM image. Further to the features of this system, the software package is the minimum dose system, which is essential for cryo-imaging, but it has now been greatly enhanced to have more than 10 different modes or conditions that can be set. And not just the deflector coil system, but any functions related to the TM and the camera system can be subject to preset conditions, allowing semi-automatic imaging beyond the original purposes of the minimum dose system. This system also has a position assist function, which allows you to graphically confirm and set the field of view of your electron beam radiation areas, depending on which of your minimum dose systems you set up. So it basically allows you to have full control over where your sample is being exposed to dose. Then there's also software available for tilt series tomography reconstruction. So it allows easy setup of tilt series data collection. And there's an autopilot feature that allows automatic region of interest detection based off of low magnification data. So what this allows you is to do multiple areas of data collection can be done over longer overnight experiments. with the comfort of knowing that your region of interest will always be kept in view. There's the JEOL Composer software, which is the tilt series processing software to allow you to do your tomogram reconstructions. And then JEOL also has software for volume rendering, segmentation, and data analysis. Now, this software allows a variety of 3D volume representation methods, such as volume rendering, multi-slicing, isosurface plotting, and it also employs various segmentation tools to streamline your volume segmentation processes, and it's got movie makers and 3D measurement tools and all the things that you need to extract 3D quantification data out of your samples. However, the GEM 120i is also fully compatible with third-party data collection software packages such as Serial EM that, as we know, supports montaging, batch tomography, single particle analysis, CLEM, and many other different kinds of applications. But now, to allow the ultimate level of customizability and flexibility, the scripting function, which is called PyGem, which is based on Python scripting, which has been originally built for the high-end JEOL TM models, is now also available for the entry-level, for the general purpose TM. This functionality allows you to control the TM lenses, deflectors, apertures, detectors, basically anything that the microscope can do. And this scripting tool allows you to support in creating automation algorithms. And with automation comes increased operation efficiency and data generation throughput. And here we see some examples of PyGem widgets that allow increased flexibility and control over your microscope conditions. So we've got our in-house software developer created some Python scripting to allow different kinds of functionalities specifically to customers' needs. That was not necessarily within the remit of the base microscope software. However, with scripting, basically, you can do anything that your heart desires. Now, the final part of the talk, I'd just like to spotlight a few application examples from the new TM. In the first instance, we just see a basic TM imaging. Here we've got a chloroplast from carrot leaf, I believe. And even though the data was acquired at 120 kV, the contrast is still excellent. Here we see an example of the power of utilizing the JEOL developed silicon nitride window. This specimen plate using high strength silicon nitride enables you to observe areas of 2 millimeters by 1 millimeter without any grid bars being present. Additionally, you can observe specimens mounted on the same window on an optical microscope, so you can advance your research on both different kinds of microscopes. And also the stub itself is chemically resistant, so you can do your staining in place as well. Basically, what was represented here was a montage of a few series of data collections at very large field of view, but high pixel resolution, which basically just allows you to keep on zooming in and enjoying the benefit of not having grid bars interrupting your data collection. If we were to now take that one step further and combine this with a modification to the sample holder, which makes use of a motorized quad silicon nitride window holder, this allows you to load a significantly larger amounts of sections into the TM at one go. So in this case, this was a serial section TM experiment whereby 200 sections were loaded into the TM with one loading session. So basically what happened was every silicon nitride grid contained approximately 50 or so serial sections. And then what the interest was for this little piece of work was to visually reconstruct a single cell, and it took 177 images in this case to view all of the images in the cell. But then specifically what was that's how one of the images look. Specifically what was intended for this was to allow with convolution neural networks to train automatic segmentation databases to find chloroplast and cell walls for us. So 5 sets of data was used to train, and then that allowed us to recreate the ability to segment out the chloroplast, and then the chloroplast volumes could easily be measured, but also within the chloroplasts, the following training data set was used in order to automatically segment for the thylakoid membranes, which allowed us again to do quantification measurements on the thylakoid stacks within the chloroplast, within the largest cell that has been isolated or imaged, all with just a single loading session of the microscope. And also, tilt series tomography is perfectly capable of being done with the system, with the JEOL high tilt retainer. You can tilt up to plus or minus 80 degrees. And here was just a screenshot of cilia cells that can be imaged. And basically, that's it for me in terms of my presentation. It's nice, short and sharp, but I leave open some time for questions. So if there is any questions, please, by all means, feel free to ask.